Hello guys, welcome back to our channel. In an era where artificial intelligence is evolving faster than ever, large language models, or LLMs, stand at the center of innovation. From answering questions to writing code, composing music to analyzing legal documents, LLMs are transforming every corner of human activity. But how do we make these massive, billion-parameter models efficient, adaptable, and cost-effective for real-world use? The answer lies in a new wave of optimization techniques, LoRA, QLoRA, and fine-tuning, revolutionizing how we train and deploy these powerful models. Welcome to Demystifying LLM Optimization, LoRA, QLoRA, and Fine-Tuning Explained, where we break down complex concepts into clear, practical insights. Whether you're an AI enthusiast, developer, or business leader, this video will equip you with a deep understanding of how LLMs are being optimized for the future. To understand why optimization techniques like LoRA and QLoRA are necessary, we first need to explore the core challenge: fine-tuning large language models, or LLMs. At the heart of every LLM are billions of parameters. For instance, models like GPT-3 have 175 billion, while GPT-4 and LLaMA 2 models stretch even further. Each parameter is a weight in the neural network, representing what the model has learned during pre-training. When we perform fine-tuning, we're taking a pre-trained model and training it further on a new, task-specific dataset. The goal is to adapt the model's general knowledge to a specialized domain, like legal contracts, medical diagnoses, or customer support dialogues. But here's the catch: traditional fine-tuning modifies all of the model's parameters. That means retraining tens or hundreds of billions of weights just for a specific use case. This process is not only computationally expensive, often requiring multiple high-end GPUs or TPUs, but also time-consuming, sometimes taking days or weeks depending on the dataset and model size. And all that cost scales up every time you want to fine-tune for a new domain or client. The three core challenges of full fine-tuning are high cost, memory inefficiency, storage and deployment complexity, introduction to fine-tuning. Imagine you have a model like GPT or LLaMA that's been trained on a massive and diverse dataset, everything from books and articles to code and conversations. This model has a general understanding of language and knowledge. But when you want it to perform a specific task, like translating legal documents or summarizing medical records, general knowledge is not enough. That's where fine-tuning comes in. Fine-tuning is the process of continuing to train a pre-trained language model on a smaller, targeted dataset so that it can specialize in a new domain or task. In technical terms, you're adjusting the model's weights based on new examples so it better understands the patterns relevant to your application. The result? A more accurate, more efficient, and more aligned model for your specific needs. For example, a base model might struggle with legal jargon. A fine-tuned legal model could draft or analyze contracts with remarkable fluency. Fine-tuning became popular as a way to improve task-specific performance, align models with organizational values or tone, and personalize experiences for individual users or industries. There are even different flavors of fine-tuning. Supervised fine-tuning, where models learn from labeled examples. Reinforcement learning with human feedback, RLHF, used in models like ChatGPT to align with human preferences. Now move ahead with LoRA, Low-Rank Adaptation Explained. This groundbreaking technique solves one of the biggest pain points in AI development: the inefficiency of full fine-tuning. Let's break down what LoRA is, why it works, and how it's revolutionizing the way we adapt large language models. At its core, LoRA is an efficient fine-tuning technique that allows us to adapt a pre-trained model without updating all of its parameters. Instead, LoRa introduces a set of small, trainable matrices, called adapters, that are inserted into the existing layers of the neural network. Here's how it works. In standard fine-tuning, the full weight matrices, like W1 and W2 in the transformer layers, are updated. With LoRa, these original weights are frozen, meaning they're not changed at all. Instead, LoRa adds two tiny matrices, A and B, where A has fewer rows and B has fewer columns. These matrices are trained so that their product approximates the change we would have made to the full matrix. This low-rank approach gives us massive savings. First one, up to 10x or more reduction in trainable parameters. Less GPU memory required. How LoRa works in practice. Instead of retraining the whole model, LoRa lets us train just the adapters, which learn the specific tone, terminology, and intent of customer conversations in retail. The original model retains its base knowledge, and the adapters add task-specific intelligence. Training efficiency. In traditional fine-tuning, training a 7B parameter model might involve updating all 7 billion parameters. With LoRa, you may only need to train around 5 to 20 million parameters, less than 1% of the original size. Modular fine-tuning and reusability. You can create separate adapters for different domains, like legal, healthcare, or education, and swap them out on the fly. LoRa use cases in the real world are fine-tuning customer service bots tailored to specific industries, building multilingual models that can adapt to regional language patterns. Next comes QLoRA, Quantized LoRA, a game-changer. Introducing QLoRA, short for Quantized Low-Rank Adaptation. QLoRA is an enhancement over LoRa. It combines two powerful ideas. First, LoRa's efficient adapter-based fine-tuning, and second, quantization, a technique that compresses model weights by reducing their precision. The power of quantization you can see. When you quantize a model, you're replacing high-precision numbers with lower-precision approximations. For example, instead of storing a weight as a 32-bit float, QLoRA stores it as a 4-bit integer and reconstructs it during training. This reduces memory and computational load by up to 80%. Technical innovations in QLoRA. Begin with 4-bit normal float, NF4, quantization, a new 4-bit data type that preserves more information than standard 4-bit integers. Secondly, double quantization compresses the quantized weights even further to save memory. Real-world impact of QLoRA. You can fine-tune models like LLaMA 7B or even 13B on a single consumer GPU or a low-cost cloud instance. Open source and community adoption. QLoRA quickly became a favorite in the open source community. It's integrated into Hugging Face's ecosystem and works seamlessly with tools like transformers, PEFT, parameter-efficient fine-tuning, and bits and bytes. Real-world applications and success stories. Number 1. Healthcare, enhancing clinical AI tools. Large hospitals and health tech startups have used LoRa and QLoRA to fine-tune language models on clinical notes, lab reports, and diagnostic dialogues, without uploading sensitive data to external servers. After that, customer support, smarter, more accurate bots. Next one, legal tech, domain-specific summarization, identify risks, summarize lengthy documents. Next is finance, regulatory compliance and risk analysis compliance documentation, transaction records, and risk evaluation procedures. Afterwards, education, personalized learning at scale, tailored quiz generation, explanations at different difficulty levels. Then, multilingual AI, efficient language adaptation, capture cultural nuances, improve translation quality, and respect local idioms. Last one, open source success, Vicuna, Guanaco, and more. When should you use which? Initial one, full fine-tuning, maximum control, maximum cost, when to use. Full fine-tuning, you're working at an enterprise scale with massive budgets. You need to deeply customize every part of the model. Subsequent one, LoRA, adaptability with modularity. When to use LoRA? You want to fine-tune on a domain-specific dataset. You need modular adapters for different tasks. For example, chatbot, summarizer, sentiment analyzer. You want to deploy updates quickly without retraining the core model. Third one, QLoRA, cutting costs with minimal trade-offs. When to use QLoRA? You want full LoRA benefits but have limited hardware you're deploying on the cloud or consumer-grade machines. You're experimenting, prototyping, or part of a startup or solo dev team. If you have deep customization needs, tons of compute, and mission-critical accuracy, go with full fine-tuning. If you want modular, reusable components with good performance, use LoRA. If your hardware and budget are tight, but you still want to fine-tune powerful models, QLoRA is your best bet. Now move on to the conclusion. We're entering a golden age of language models, where intelligence is not only vast but also adaptable. Optimization techniques like LoRA and QLoRA are not just academic experiments, they're real-world solutions empowering individuals and companies to harness AI affordably and efficiently. As models grow more powerful, these techniques will be critical in keeping AI accessible, sustainable, and innovative. Thanks for watching. If you found this valuable, like, share, and subscribe for more deep dives into AI innovation.